Okay, so let's talk about this one. I'm hoping you gave it an attempt at least before watching this video. What's really interesting is that equation that we just wrote in the previous problem. So the D equals, here, let me write that. D equals 16t squared. This is an equation that's actually like seen in the real world. So it was first found by this scientist named Galileo Galilei. I think is how you pronounce his name. But a lot of other scholars at the time also studied what happens when you just drop an object, when it's just free falling in the air. And this describes the speed that it's going to fall. It's going to keep going faster and faster. You know, if you imagine, dropping a penny off the top of a really tall building, by the time it gets to the ground, it's going to be going fast enough to really hurt someone. So that's why that's not a good idea to do. And so, so we're thinking now of an object. We've got like our building, and it is 576 feet tall. Okay. And then we're dropping this object off the top of it and thinking about how far it's going to have fallen. So after 0.5 seconds, well, that would be when the time is equal to 0.5. So I'm going to plug that in. So D would be 16 times 0.5 squared. So the distance fallen here would just be 16 times 0.5 squared. I'm doing that on my calculator. That's 16 times 0.25, which is equal to 4. So it's only fallen 4 feet. So right now it would be 576 minus 4, which is 572. Okay, so Diego and Elena were thinking about this. They were thinking about this problem. And Elena thought of it more as the distance fallen. So after 1 second, it's 16. After 2 seconds, it's 64. After 3, that would be 16 times 3 squared, which is 9. So that would be 144. After 4, it'd be 16 times 4 squared, which is 16. So that would be 256. These numbers should look familiar because they're the numbers we just did on the last activity. So in general, the equation is 16t squared. That's how far it's falling. If I'm just thinking about the distance traveled, after how many seconds, how far has it fallen down? Okay. Now, Diego thought about it a little bit differently. Diego thought about, hey, if we've gone down 16 feet and I take 576 minus 16, I have 560 left. So that's the distance up, right? If I've gone down 16 feet, I still have 560 here. You see the difference there? So Elena's thinking about the distance from the top, where Diego's thinking about the distance from the ground. And so he's taking this number and subtracting it then. So 576 minus 64 gives you 512. 576 minus 144, that's how far it's fallen after 3 seconds. This would be 432. 576 minus 256, it's going to be 320 after 4 seconds. So in general, the distance above the ground, well, it started at 576, and then we're subtracting the 16t squared from it. And we're going to see equations written a lot like that. So this 576 minus 16t squared. The 576, that's my initial height. Right? That's how high the building was. And then the 16t squared, that's the effect of gravity. That's it falling over time. In fact, this negative 16 there, that factor in front of the t squared. Why my computer's not letting me write gravity. Sideways. Gravity. There we go. Sorry if that's hard to read. But yeah, the negative 16t squared, that's the effect of gravity. So that's what's pulling it to the earth faster and faster and faster. That's why when you drop a penny off of a tall building, by the time it hits the ground, it's going to be going real fast.